Hello my dear students. Today we are going to start with a new chapter, Coordinate Geometry. You already have an idea about this particular chapter, Coordinate Geometry, in class 9. In class 9 you have already studied about coordinate axis, you studied about the coordinate of a point, you have studied about the quadrants, you also have studied about the signs of the coordinates of points in different quadrants. You also have an idea about the dependent and the independent variables. So with this prior knowledge, today we will start our new chapter, Coordinate Geometry. One thing I must tell you, those chapters which involve prior knowledge or previous knowledge are important chapters. So you must assure yourself that you have the idea of this particular topic which has already been discussed in class 9. So the facts and figures which remains, which are attached, which are linked with this particular topic and which has already been done in class 9, you must be updated with those concepts. So today we are going to start with this chapter, Coordinate Geometry, which was introduced by René Descartes, a French mathematician in the 16th century. There was a story involved in the introduction of this topic, Coordinate Geometry, by René Descartes. One day, René Descartes noticed a fly crawling around the ceiling of his room. He watched the fly for some time. Then he thought how to explain or tell anyone about the position of the fly, that is, where the fly was. He then realized that he could describe the position of the fly by its distance from the walls of the room. Then he tried describing the position of points in the same way as he described the position of the fly. In this way, he introduced the coordinate plane, also known as the Cartesian coordinate system, and hence he introduced coordinate geometry in the 16th century. रेने डेकार्ट ने अपने कमरे की छत के पास एक मक्खी को देखा। उन्होंने कुछ समय के लिए मक्खी का अवलोकन किया, मक्खी को देखता रहा। फिर उसने सोचा कि मक्खी की स्थिति के बारे में किसी को कैसे समझाए या बताए। फिर उन्हें एहसास हुआ कि वो कमरे के दीवारों से दूरी के आधार पर मक्खी की स्थिति का वर्णन कर सकते हैं। तब उन्होंने उसी तरह से बिंदुओं का स्थिति का वर्णन करने की कोशिश की, जैसे उन्होंने मक्खी की स्थिति का वर्णन किया। इस प्रकार उन्होंने कोऑर्डिनेट प्लेन का परिचय दिया और आज हम इसे कार्टेशियन कोऑर्डिनेट सिस्टम के नाम से जानते हैं, and also introduced the coordinate geometry in the 16th century. In this branch of geometry, a point is located in a plane with two numbers called coordinates put inside simple brackets. The coordinates indicate the distance of the point from the two axes. So now you can see that the x-axis and the y-axis divide this plane into four parts, and each part is called a quadrant. So there are four quadrants, 1, 2, 3 and 4, and P, A, B is any point in the first quadrant. Now for the point P, A, B, A is called the x coordinate or abscissa, B is called the y coordinate or the ordinate, O is the origin, this is the origin 0, 0, it is the point of intersection of the two coordinate axes. So the point of intersection of the x-axis and the y-axis is the origin. Now a point on the x-axis has its y-coordinate equals to 0 and denoted by x, 0. Examples 1, 0, 2, 0, minus 5, 0 like this. Now if the point lies on this line, on this axis, this is the x-axis. So any point on this axis will have the value of y equals to 0. So if the point is 0, supposing, and the minus 5, so it is minus 5, 0. If this side is 2 units, it will be 2, 0. So any point on the x-axis will be having its y value equals to 0. A point on the y-axis has its x coordinate 0 and denoted by 0, y. Examples 0, 1, 0, 4, 0, minus 2. So if the point lies on the y-axis, then always it will be having x value equals to 0. So any point on y-axis will be like 0, 1, 0, minus 1 like this. Okay. In geometry, we find the distance between 2 points by using a scale. But in coordinate geometry, we find the distance between 2 points by using a formula which is known as distance formula. So here, Px1, y1 is any point in the first quadrant. Similarly, Qx2, y2 is another point in the first quadrant. And here we need to find the distance PQ, that is the distance between the points P and Q. Now what we do is, we draw a perpendicular PM on the x-axis. Similarly, Qn on the x-axis. We join PR. Then PR and Mn are equal. Px1, y1 is this point. So this distance is x1 and this distance is y1. Similarly, Q is x2, y2. So this distance is x2 and this distance is y2. So we have this much Mn is x2 minus x1. So Mn equals to PR, so PR is also equals to x2 minus x1. Here we have Qn is y2 and Rn is y1. So this distance difference, that is QR, is y2 minus y1. Now we got in this triangle PRQ, we apply the Pythagoras theorem. So what the Pythagoras theorem says is PQ square equals to PR square plus QR square. So PQ square equals to PR square. PR is x2 minus x1, so it is x2 minus x1 square, and QR is y2 minus y1, so it is y2 minus y1 whole square. So PQ is the square root of x2 minus x1 square plus y2 minus y1 square, and since this is square, we can also write it as x1 minus x2 square plus y1 minus y2 square. That can also be written. Now distance of any point Pxy from the origin. So if the point is, suppose this one, and the distance of its distance from the origin, so this distance OP is given by root over x minus 0 whole square plus y minus 0 whole square. 0 because the coordinates of the origins are 0, 0. So it comes to root over x square plus y square. So distance of any point from the origin is given by root over x square plus y square. Now let us solve the first question of this particular chapter. Find the distance between the origin and the point P minus 5, 12. So the origin, the points are the origin 0, 0 and the point P, that is minus 5, 12. So we need to find the distance between O and P. So we have OP equals to, since the distance is from the origin, we will directly write with x square plus y square, that is root over minus 5 square plus 12 square. So this comes to, this is 25 plus 144, so it comes to root over 169, and that is equals to 13 units. So there it is very simple question. Here the question was to find the distance between the origin and the point minus 5, 12. So origin is taken as 0, 0, P is minus 5, 12. So distance between the origin and the point P is given by root over x square plus y square. We put the substitute the value of x is minus 5 square plus 12 square. We get the final value as 13 units. Okay. Now we move on to the next question. The next question is, find the distance between the points. Question number 2. Find the distance between the points A4 minus 9, A4 minus 9 and B minus 5, 3. So you need to find the distance AB. So distance between A and B. AB is equals to root over x2 minus x1 square plus y2 minus y1 square. You can take any one of these as x1 y1 and x2 y2. This can be x1 y1, it can be x2 y2, anything. Now x2, if we take it as x2, so it is minus 5 minus 4 square plus 3 plus 9 square. So this is coming to 5 plus 4 9, so it is 81 plus 12 144. So it is coming to root over 225. So it is coming to 50 units. So the distance between the points A and B is coming to 15 units, right? Next question. So in question number 3 we have, if a point A 7 minus 8, if a point A 7 comma minus 8 and point B is on x-axis and point B is on x-axis, find the coordinates of B. Find the coordinates of B if AB equals to, if AB is 10 units. So here in this question, the distance between the points A and B is already given, that is equal to 10 units. The point A is 7 minus 8, you need to find the point B which is on the x-axis. So you know that any point on the x-axis is given by x comma 0 because the value of y on the x-axis is 0. So the point A given as 7 minus 8 and let the point B on the x-axis is x comma 0. So we are given AB, the distance AB given as 10 units. So now we have AB is equals to root over x minus 7 square plus 0 plus 8 square. What is AB? That is 10. So if you square it, 10 square equals to, this is x minus 7 square plus 64. So this is 100 minus 64 equals to x minus 7 square. So we have x minus 7 square equals to 36. So if you write x minus 7, that is equals to plus minus 6. So it is x minus 7 equals to 6 and x minus 7 equals to minus 6. So x equals to 13 and x equals to 1. So the points are, it can be the point B can be 13, 0 or 1, 0 because the value of x is coming to 13 and 1. So in that case, if the coordinates of B are x, 0, so it is 13, 0 and 1, 0. Is it okay? Now we move on to the question number 4. Now in question number 4 it says the coordinates of M and N. The coordinates of M and N are minus 2, 4, are minus 2, 4 and 6B and 6, B. Find the value of B. Find the value of B if Mn equals to 17 units. Mn equals to 17 units. Very similar to question number 3. m is minus 2 comma 4 and n is 6 comma b. So this unknown b is to be found. The distance mn is given equals to 17 units. So we have mn equals to root over 6 plus 2 square plus b minus 4 square. If we write mn equal to 17 and square it, so this becomes 17 square. We are squaring both sides because we want to get rid of this square root sign symbol. Okay, so this is equals to 8 square is 64 and plus of b minus 4 square. So this is 289 minus 64 equals to b minus 4 square. 225 equals to b minus 4 square. So you can write b minus 4 equals to plus minus 15. So we have b minus 4 is equals to 15 and b minus 4 equals to minus 15. So b equals to 19 and b equals to minus 11. So the value of b is either both b equals to 19 and b equals to minus of 11. So have a look, we move on to the next question, that is question number 5. Now question number 5. Point P is on the x-axis and it is equidistant from A 8 minus 4 and B 1 comma 3. Find the coordinates of P. Mind it, the point P is on the x-axis. That means if you have to take any point on the x-axis, it will be in the form of x comma 0. That is y is 0 on the x-axis. So the point P is x comma 0. It is equidistant from A. If it is A, that is 8 minus 4 and B, that is 1 comma 3. So that means we have PA equals to PB. PA equals to PB because P is equidistant from the 2 points A and B. So we can write it as PA square equals to PB square. In that case, what will happen? Directly we are removing the square root part. So PA square, we can write it as 8 minus x square plus minus 4 minus 0 square is equals to 1 minus x square plus 3 minus 0 square. So we have here this side, so 64 minus 16x plus x square plus 16 equals to 1 plus minus 2x plus x square plus 9. So x square and x square will cancel out. We have minus 16x plus 2x plus 64 70 80 and minus 10 equals to 0. So minus 14x is equals to minus 70. So x equals to 5. So the coordinate of the point P x0 is 5 comma 0. So the point P is 5 comma 0. Here. So here we repeat once again, P is the point on the x-axis, so we have taken it as x comma 0. It is equidistant from the 2 points A and B, that is PA equals to PB. So we write PA equals to PB, squaring both sides, we get PA square equals to PB square. So we write 8 minus x square plus minus 4 minus 0 square equals to 1 minus x square plus 3 minus 0 square. Solving this, we get the value of x equals to 5. So the coordinates of the point P, which is on the x-axis, is given by 5 comma 0. Okay. Now we move on to the next question, that is question number 6. Now question number 6 is prove that a 16 minus 8 b 4 minus 3 comma minus 3 and c minus 8 comma 2 are collinear, that is lie on the same line, So now first of all, the condition for collinearity of 3 points is that AB plus BC should be equals to AC, or BC plus AC should be equals to AB, or AB plus AC should be equals to BC. So either AB plus BC equals to AC, or BC plus AC equals to AB, or AB plus AC equals to BC. So you need to find the length of these three, AB, BC and AC. So what is AB? That is root over the point AB is 4 minus 16 square plus minus 3 plus 8 square, and that is coming to root over 144 plus 25, and that is root over 169, and that is equals to 30. Now let us find BC. BC equals to root over BC is minus 8 minus 4 square plus 2 plus 3 square. So this gives 12 square 144 plus 5 square 25. Again root over 169, that is equals to 13. Now let us find AC. AC root over minus 8 minus 16 whole square plus 2 plus 8 square. So that is equals to 24, that is 576 plus 10 square is 100, equals to root over 676, and that is equals to 26. So we have AB equals to 13 units, BC equals to 13 units, and AC equals to 26 units. So it is very clear from this particular calculation that AB plus BC is equal to AC. Hence the points A, B and C are collinear, that is they lie on the same line segment. So here we have AB plus BC is equals to 13 plus 13 equals to 26 is equals to AC. Hence ABC are collinear. Now let us see to the next question, that is number 7. Prove that, question number 7. Prove that A04, A0,4, B minus 10 and C3 minus 1, 3, minus 1 form an isosceles right angle triangle. Form an isosceles right angled triangle. So what is an isosceles triangle? That means two sides are equal. And secondly, you need to prove that this is isosceles, at the same time it is right angled triangle. So you need to find the length of the three sides of the triangle, and then we can, if you find that any two sides are equal, then you can say that that triangle is an isosceles triangle. But at the same time you need to prove the Pythagoras theorem, and if it is satisfied, then you can say that triangle is an isosceles right angle triangle. So let us find the length of the sides of the triangle. Let AB equals to root over -1 minus 0 square plus 0 minus 4 square, and that is equals to root over, we have 1 plus 16, that is root over 17 units. Then you need to find BC, root over BC, that is 3 plus 1 square plus -1 minus 0 square, and that is equals to 4 4 16 plus 1, that is root over 17 units. So here you can clearly see that AB and BC are equal and each equal to root over 17 units, hence the triangle is isosceles triangle. So AB plus BC and AC. AC is root over this one 3 minus 0 square plus -1 minus 4 square. So we have root over, that is 9 plus 25. So root over 34 units. So since AB and BC are equal, hence the triangle is isosceles triangle. Now let us prove that it is right angle triangle as well. So if we can write, so if what we have here, AB square plus BC square equals to 17 plus 17 equals to 34, and that is equals to AC square. So we have AB square plus BC square is equals to AC square, which clearly indicates that the triangle is an isosceles right angle triangle. So next question, number 8. Prove that ABCD is a rhombus. ABCD is a rhombus where A is 3, 10, A 3, 10, B minus 2, 6, C 3, 2, and D 8, 6. So in order to prove that ABCD is a rhombus, we need to prove that all the four sides are equal. So you need to find the length of the four sides, that is AB, BC, CD and TA. So AB equals to root over -2 minus 3 square plus 6 minus 10 square, and that is equals to 525 plus 416 root over 41 units. Let us find BC. 3 plus 2 square plus 2 minus 6 square, and that is equals to 5 square is 25 plus 4 square is 16, that is root over 41 units. Then you need to find CD, AB, BC, CD. CD is 8 minus 3 square plus 6 minus 2 square. So you have 5 square, that is 25 plus 4 square 16, so that is again root 41 units. Then we have finally dA equals to root over dA root over, it is 3 minus 8 whole square plus 10 minus 6 square is equals to root over 25 plus 16 root over 41 units. So we have AB equals to BC equals to CD equals to DA. Hence, it is a rhombus. So for ABCD to be a rhombus, we need to prove that all the four sides are equal, and here we have proved AB equals to BC equals to CD equals to DA, and each is equal to root over 41 units. Hence, it is a rhombus.